So in this talk, I will show you how we teach machines to understand arguments in text and how we leverage these technologies to extract arguments from big data streams in order to optimize decision processes. So you all know how a decision process looks like. So at the beginning, we need to identify the problem. This is, in the most cases, rather easy. So for example, a new technology arrives and we need to assess, we need to decide if this technology is valuable for us and if we can benefit our businesses with this technology. In order to answer this question, we need to collect data. We need to go through text streams. We need to find relevant sources where we can find evidences and so on. And this is, in most cases, manual work indeed. From these text sources, we need to extract evidence. And we need to identify pro and con arguments which help us to assess the chances and the risks, for example, of a new technology in order to make a final decision. And at the end, if we have enough data, we can make an informed decision about the actual question. So with our technology, we aim to support decision makers in the three intermediate steps. So basically in the collection of the data, in the extraction of the evidence, and in the identification of pro and arguments for any controversial topic. As you all know, the manual data collection and assessment is very, very time consuming. So basically you need to go to maybe Google or other data providers. You need to read newspapers and stuff like that to assess and to find evidence and to find information which help you in making your actual decision. And this is a very time-consuming task indeed. And it can also be error-prone because it's likely that you miss some important information. And this can generally lead to very wrong decisions and maybe even fatal consequences for your own business. Automatizing this decision-making process is nothing really new. So businesses are already gaining value by automating this process. For instance, in areas like predictive analysis, this process is automated for instance, in the area of sales forecasts, for predicting store-level demand, or for fraud detection, for instance. However, all these current systems are mainly based on structured data, numerical data, basically. However, structured data is only about 20% of the information which is available to your company or your organization. And the question is, how can you leverage the rest of the data for your decision-making process? Actually, there's a massive potential waiting for you to be leveraged, right? And we believe that argument mining is one technology which can do that, and this technology can be used to use the potential of this massive amount of unstructured data and to incorporate it into your decision-making process. So what is argument mining? Argument mining is basically a way to extract arguments, textual arguments, from any kind of text. So imagine you have a given controversial topic, for instance, a new innovation, a new technology, and you want to learn more about that. And you don't know if it's positive or negative, and you don't know the chances and risks and so on. So with argument mining, you can extract pro and con arguments from multiple textual sources, for instance, the entire web. These systems are mainly based on supervised machine learning techniques, so you need training data for that. We are currently employing several kinds of deep neural networks for these tasks, but the main challenge here is to generate the training data. As you can imagine, teaching machines what an argument is not a very easy task, so you need really massive amounts of training data, and the question is how you can get that. So basically what these methods do, we have a huge pile of unstructured text, for instance, newspapers, scientific papers, comments on social media, whatever. What we want to do, we want to extract arguments from these texts. So basically we want to find evidences which can be used to support or to attack my current topic, basically. And at the end, we want to sum up these arguments in a nice pro-con list to get an overview and to learn more about the chances and risks, for example, of a technology or another controversial topic which we need to make a decision on. To give you one example, such a topic could be autonomous trucks, right? It's a controversial topic which is frequently discussed, and what such a method could extract from text is, for instance, this is indeed a real example that we extracted from a web corpus, basically. The following pro argument, which tells us that the use of such technology will reduce fatal truck and bus accidents by 20%, resulting in 800 less deaths on European roads, which is a quite strong pro argument. However, it also identifies con arguments, like, for instance, these components are still expensive today. What are these components? Those are spinning light emission radar systems, so I don't know what that is, but maybe you know better. That grounds most current autonomous vehicles cost upward to 70,000. I think this is a little bit outdated. I think they have become cheaper in the recent past. But anyway, you can see some examples here of arguments which our technology really extracted from unstructured text, basically. And I think it's obvious how such kind of arguments can be used to optimize your own decision making. However, using these technologies in real industrial settings comes with some challenges. So argument mining is a very recent research field in natural language processing, which started basically in 2014 with the first workshops on international conferences. And most of the current approaches coming from fundamental research are limited to particular text types. For example, there are approaches which work well for social media files. There are other approaches which work well with student essays, and other approaches which work well with legal documents. However, what we actually want, we want to be able to apply these methods to any kind of text, to make really use of the entire data which is available. And the current methods have a really hard job to generalize over these different kinds of texts. You can easily imagine that, for example, arguments in social media are quite different than arguments found in newspapers, right? And this is a big challenge for the methods. So heterogeneity is one of the most crucial challenges for applying these methods in industrial settings. The next point is scalability. So as I said before, these methods require a huge amount of training data, and creating this training data is a very time-consuming job, and usually it's done by expert annotators. Identifying arguments is quite complicated, even for humans. So you can imagine if you want to identify conclusions, premises, evidences, and relations in a huge document, this can be quite time-consuming. So we have a problem with scalability. So basically we need to enhance the generation of the training data generation. And finally, robustness. We don't want that the system is only able to find arguments for one particular domain or topic. We want that the method works for, in the best case, for all different kinds of topics. And what we are currently doing, we have a project funded by the Federal Ministry of Education and Research, and we are currently approaching these challenges and validating the technologies from fundamental research. And what I will show you on the next slides is basically a solution to all of these three challenges. So data generation. I already told that we need data, and the question is, how do we get that? So, and we want heterogeneous data. So basically what we did, we didn't focus our data collection on a particular type of text as it was done before in fundamental research, but we used a really heterogeneous text collection. And we acquired this corpus by using web searches, for sure, because in the web you can find all different kinds of documents, right? And we did that for more than 40 different topics to be able to evaluate the methods across different domains or topics, respectively. And then we used crowdsourcing, indeed, and evaluated the quality that we could obtain using crowd workers. So basically, we asked our crowd workers to label a given text as either pro or con argument. So basically, we just showed them a piece of text, and they should say, okay, is it pro or con and relevant to our topic or not? And as I said, we use crowdsourcing, which allows us to obtain a huge number of annotated data in a very short period of time. However, when you use crowd workers for creating data, the problem is data quality. So we don't know if the crowd has really understood the task, if our instructions have been okay, and so on. So data quality is really an issue. In order to evaluate the results of crowdsourcing, we compared the results of expert annotators. These have been basic graduate-level language technology researchers from our lab to the results of crowd workers. And what you can see here are basically some domains, right? In this case, 8 different domains where we conducted our experiments on, that the crowd is actually able to solve this task quite well. So in some topics, the crowd achieved actually better performance, a better agreement than the expert annotators. So to give you some numbers of this quality, so yeah, as I said, crowd workers are able to annotate arguments in text with a high agreement, and the agreement, we measure that with kappa, which are some inter-annotator agreement measures, which give us an idea about the subjectivity of the task, is quite reliable here. So if the measure is above 6.8, you can say it's really a reliable data that you get. And we also found that this process is really scalable. So we have been able to get data about 40 plus different topics, so I think it was about 50, in less than a week using 750 crowd workers. And with this process, we have been able to create a corpus with more than 50,000 instances with high quality annotations. So what do we do with that? For sure, we train our deep learning models, right? And here you can see a schematic of one model. This is already a little bit outdated, so we have newer models which perform a little bit better. Anyway, so we are using a deep learning architecture which does not require any manual feature engineering. This is basically a common bidirectional LSTM model for sequence labeling. We integrated an attention mechanism that allows us to learn the relation of a given topic and the relevance of a given topic, which you can see here on this slide with respect to the sentence, and it's able to learn an importance rating and to determine which words of a sentence make a sentence an argument and which words are generally responsible for a sentence to be an argument. And a nice feature on top is that using such an attention mechanism results in somehow an interpretable learning process. So you can basically see the weights that it assigns to particular words and to interpret how the model makes the decision. And in addition, it's also quite fast. So if the model is trained, we can make 1,000 decisions in less than 1.4 seconds, including the entire pre-processing, which is quite okay. So I already talked about robustness and mentioned that we want our models to perform good over different topics. So we don't want that the model performs only good in one domain. In the best case, it should generalize to several different domains. So we conducted in-topic and cross-topic experiments. Here you can see the in-topic experiments. In this setting, the model basically knows the topic. So it has seen the topic during training, and in this setting, we achieve something about a 74 F-score, which is quite okay. However, the more challenging setup is cross-topic experiment. Basically, we train our model on a set of documents, on a set of topics, and apply it to another topic which has not been seen before. And this is what we want to improve on, basically. The middle results here show what happens when we train the model on only 8 topics. There, the performance decreases to around 8%, sorry, basically. However, what you can also see here in the third part of this bar chart is that if we use many topics, if we train our model on 40 different topics, then the performance is almost as good as in domain. And this shows that the model really generalizes well over different topics, and we lose basically only 1% if the model has never seen the topic before. And it's really able to understand now arguments for different topics without ever having seen this topic, which is quite fantastic, I think. So yeah, we have also been able to outperform several baselines, and we are continuously improving these models. So we are currently experimenting with adversarial multitask learning setup, but I will not bore you more with these results. We also compared the model to human performance and found that our current system achieves almost 85% of the experts, which is also quite a nice result. So it performs almost as well as human annotators, basically. So how do we use that? This is maybe the most interesting part. We are currently collaborating with Daimler AG in the area of innovation management. So we are collaborating since, I think, 1.5 years now, and we apply these methods for innovation assessment. So basically, what we want to do, a new technology arrives, and we want to know, is this technology mature enough? What are the risks? What are the risks of these novel innovations? What are the chances? And is it worth investigating in this technology? Those are all questions which are really, really tough to answer, right? Because you don't know anything. You just get a new news article from TechCrunch and you see a new technology, but you have no idea if it's really mature or if you can really use it, if it's already there, right? And if it's really helpful for your own business. So yeah, answering these questions is very tough. What we actually want to do, we want to assess the advantages and disadvantages of a new technology, and we want also a continuous monitoring of relevant sources if new arguments or new research findings which are related to a new innovation come up. So what we did to realize such a system, we applied our argument mining methods to heterogeneous sources. So basically, we implemented a search engine which allows you to search for any controversial topic in a huge data collection. What we did for that, we used basically a copy of the web. It's a web corpus for our first demonstration system. This includes 400 million English web pages. So basically, we used Common Crawl and removed all other languages, all images and videos and so on, and extracted the plain text. And it includes, I guess, 861 GB of plain text currently. Then we separated the system into offline processing, which is very time-consuming. So basically, we removed the boilerplate, we splitted the sentences, did some linguistic analysis, and indexed the entire corpus using Elasticsearch. So basically, until here. So at this point, we are able to search this massive amount of text data. And during online processing, we first retrieved documents which are relevant for the user. So the user provides a particular topic she or he is interested in. Then we retrieve some documents and later apply our argument mining models to that to extract pro and con arguments. And then we present them in a web interface in a nice pro-con list. The web interface also includes some other functionalities like source filtering, and we are also able to rank the documents that are relevant to the topic by the number of arguments, for instances, and showing some bar charts about the results and stuff like this. So this is what we did for the innovation use case. And here you can see a real screenshot of that. And this is really not a fake result, it's a real result. So what you can see here on the pro side is something, so I searched for self-driving cars here. And what you can see on the left side is something like that self-driving cars can significantly reduce traffic congestion. You can see something like it will reduce emission and improve air quality. What else? And it will result in safer traffic, basically. On the con side, you can see some information about security concerns because these systems may be easily hacked, I don't know. And there are some other unique safety problems. And here is a concern that these systems may have problems to drive in particular conditions like busty city driving and extreme weather conditions. So this is just a use case to illustrate that our technology is indeed able to extract arguments from the entire web indeed. This version is currently only available for English language, but we are also working on adapting this technology to other languages. In particular, we want to build our models for German as well. And for that, we are using some bilingual word embeddings and multilingual deep learning approaches, which allow us to learn our model in one language and apply it directly to the other language. And in our recent experiments, we found that this increases the performance by only around 2 or 3%, which is also quite nice. Yeah, to sum up my talk, I presented a new technology to you. This is argument mining, and I believe that this technology has the potential to unlock the potential of unstructured data for decision making. And as you have seen, this technology also enables new search paradigms, which allow you to extract arguments from any kind of text in more or less real time indeed. Some of our research findings are that the training data can indeed be reliably created using crowdsourcing, and that the approach requires only very few training examples to adapt to other domains or topics. So it generalizes quite well indeed. And it achieves up to 85% of human performance. The unique selling points of this concrete technology compared to other research labs, for instance, is that we are able to extract arguments from any type of text, so basically heterogeneous types of text, and our technology is not limited to a particular text type. We are using innovative machine learning models, deep learning models basically, and we are still extending them to get even better results. Yeah, I hope that I could arouse your interest in this new kind of technology, and yeah, thank you a lot for your attention. Thanks.